Imagine waking up one morning and being told that, somewhere in the world, a massive multi-story building has just been completed, not in a week, not in a month, but in a single day, 24 hours. For most of us, that sounds impossible, almost like something pulled from a science fiction movie. We've been conditioned to believe that large buildings take endless months of noise, dust, cranes standing still, and workers slowly moving from one floor to the next. So when news broke that engineers in China had pulled off exactly that, the world didn't just pause it stared in disbelief. Think about what usually happens on a construction site. Foundations take weeks. Concrete needs time to cure. Steel frameworks rise slowly, one level at a time. Delays are expected, weather becomes an excuse, and deadlines are pushed back again and again. Now contrast that with a structure going from the ground up in just one day. Not a temporary shelter, not a simple shed, but a real functional building with multiple floors designed to last. That's why this moment wasn't just impressive, it was shocking. What made it even more unbelievable was how calm and controlled the entire process looked. There was no chaos, no rushed panic, no workers scrambling at the last second. Instead, everything moved with clock-like precision. Cranes lifted massive sections into place as if they were weightless. Teams worked in perfect rhythm, each group knowing exactly what to do and when to do it. It was less like a construction site and more like watching a carefully rehearsed performance. And here's the part that truly messes with your expectations. This wasn't a reckless race against time. Safety checks were done. Structural integrity was tested. The building wasn't just standing. It was stable, functional, and ready for use. That alone challenges one of the biggest assumptions we all carry, that speed automatically means lower quality. What China's engineers demonstrated was the opposite, that with the right preparation, speed can actually be a sign of mastery. The world has seen fast construction before, but never on this scale and never with this level of confidence. Normally, when we hear built fast, we think corners were cut. But in this case, the speed was the result of extreme planning long before the first crane ever moved. Every measurement, every joint, every connection had already been calculated down to the smallest detail. By the time construction day arrived, there was nothing left to figure out, only execution. That single-day build sent a powerful message. It wasn't just about setting a record or grabbing headlines. It was about proving what's possible when engineering meets discipline and vision. In just 24 hours, China didn't only raise a building. It raised questions in the minds of engineers, architects, and governments around the world. If this can be done once, why not again? And if again, why not everywhere? People watching from other countries couldn't help but compare it to projects in their own cities. Projects that drag on for years, draining budgets and testing patience. Suddenly, the idea that this is just how long construction takes no longer felt true. A new benchmark had been set, and it made the rest of the world uncomfortable in the best possible way. This wasn't luck. It wasn't a miracle. It was the result of years of pushing limits, refining systems, and refusing to accept slow as normal. That's why this moment matters, because once the impossible becomes visible, it stops being impossible and starts becoming the future. And that future was built in just one day. Now here's where the story gets even more fascinating, because the real magic didn't happen on the construction site at all. It happened long before, inside massive factories where buildings are no longer treated as projects, but as precision products. Instead of pouring concrete and cutting steel in open air, exposed to weather, delays, and human error, China's engineers flipped the entire process. They moved construction indoors, where time, quality, and accuracy could be controlled down to the smallest detail. Imagine an entire building being created in sections, each one carefully engineered, measured, and tested before it ever leaves the factory floor. Walls, floors, staircases, and structural frames are all produced separately, but designed to fit together perfectly later. It's not so different from how airplanes or cars are made. You don't build a jet on the runway. You manufacture each part in a controlled environment, then assemble it with absolute precision. That same mindset is what allowed these buildings to rise in a single day. Inside these factories, machines don't get tired. Measurements don't change based on weather. Every component is identical to the digital design that engineers created months earlier. This eliminates one of the biggest problems in traditional construction: inconsistency. When every piece is made the same way, the final structure becomes stronger, safer, and far more predictable. And when predictability is high, speed naturally follows. By the time these massive building sections arrive at the site, most of the work is already done. Electrical channels are pre-installed, insulation is already in place, structural joints are engineered to lock together with millimeter-level accuracy, so instead of building from scratch, workers are simply assembling. That's why it can look almost unreal, like a time-lapse video happening in real life. What's truly remarkable is how this approach completely changes the role of the construction site. Instead of being a place of uncertainty and improvisation, it becomes more like an assembly stage. Cranes lift finished sections into position, crews secure them, and the building grows vertically with astonishing speed. No waiting for materials, no rework, no guessing. Everything has already been decided. This method also solves problems most people don't even think about. Traditional construction creates massive waste, unused materials, mistakes that require demolition, and constant transportation back and forth. Prefabrication dramatically reduces that waste. Materials are used efficiently, errors are caught early, and energy consumption drops. Speed isn't the only advantage here. Sustainability is quietly built into the system. There's also a psychological shift happening. When engineers know that every component has been tested before arriving on site, confidence replaces hesitation. Workers move faster because they trust the process. Decisions are simpler because the complexity has already been handled behind the scenes. That trust is what allows an entire building to come together without stopping to rethink every step. And let's be clear, this isn't cheap or low-quality construction. In fact, it often results in stronger buildings. Factory-controlled production means better welding, tighter seals, and more consistent materials. What looks fast from the outside is actually the result of slowing down where it matters most, during design and manufacturing. Speed on the site is earned through patience in preparation. This is why the one-day construction wasn't a lucky experiment. It was the natural outcome of a system designed to remove randomness. Once the building blocks exist, once every detail has been perfected, assembling them in hours becomes not just possible, but logical. The real surprise isn't that the building went up so fast. The real surprise is realizing that this way of building has been available all along, and only a few were bold enough to fully embrace it. Because when construction becomes assembly, time stops being the enemy and starts becoming an advantage. But even with perfectly manufactured building sections, none of this would have been possible without something even more impressive than machines or materials. What truly made this one-day construction a reality was the level of coordination behind it. This wasn't just a group of workers showing up and doing their jobs. This was a massive human system moving with almost military-level discipline, where every person, every machine, and every moment was synchronized long before the first piece was lifted into the air. Imagine hundreds, sometimes thousands, of people all knowing exactly where they need to be, what they need to do, and the precise second they need to do it. There was no confusion, no overlap, no waiting around for instructions. Each team had a clear role, and each role fit perfectly into a larger plan. When one group finished, another was already in motion. Like gears inside a clock, everything turned together, smoothly and relentlessly. What's remarkable is that this level of coordination doesn't happen by accident. It comes from detailed planning that leaves nothing to chance. Every movement on the site had already been simulated and rehearsed. Engineers didn't just design the building, they designed the process of building it. They mapped out how cranes would move, how trucks would arrive, how crews would rotate, and how long each task would take. The actual construction day was simply the execution of a plan that had already been perfected on paper and in digital models. This is where discipline becomes a force multiplier. When people trust the system and trust each other, hesitation disappears. No one is stopping to ask what comes next. No one is guessing. Everyone is focused, confident, and fully aware that even a small delay could affect the entire chain. That shared responsibility creates a sense of purpose that pushes performance to another level. There's also something deeply cultural at play here. This kind of coordination reflects a mindset where collective success is valued more than individual recognition. The goal isn't for one person to stand out, but for the entire operation to succeed. In an environment like that, ego fades away and efficiency takes over. People don't compete for credit, they compete against time. Technology supports this coordination, but it doesn't replace it. Communication systems keep teams connected in real time. Sensors and monitors track progress down to the minute. But at the core, it's human discipline that holds everything together. Machines can lift and move, but only people can make decisions, adapt instantly, and keep momentum alive when pressure is high. What makes this even more impressive is the absence of chaos. Fast projects usually feel frantic. Mistakes happen. Tempers flare. But here, speed created calm instead of stress. Because everything was planned, workers weren't rushing blindly. They were moving confidently. Speed wasn't forced, it was natural, and when problems did appear, as they always do, there was no panic. Backup plans were already in place. Teams adjusted without slowing the entire operation. That's the sign of a mature system, one that expects challenges and prepares for them instead of being surprised. This kind of coordination also changes how time is valued. Minutes are treated like precious resources. Transitions are seamless, idle moments are eliminated. When multiplied across hundreds of workers and dozens of machines, even small efficiencies add up to massive time savings. That's how a day suddenly becomes enough. Watching this unfold forces you to rethink what's possible when people work together at this level. It challenges the idea that large teams are automatically inefficient. In reality, when alignment is strong, size becomes an advantage. More hands don't slow things down, they accelerate progress. This wasn't just construction, it was orchestration. Every move had meaning, every action had a purpose, and every person played a role in something bigger than themselves. And when humans move with that level of unity, even time has no choice but to step aside. Now let's talk about the silent force behind everything you've just imagined, the one working tirelessly in the background while cranes move and crews coordinate. This entire achievement rests on technology so advanced that it almost disappears from view, yet without it, none of this speed would exist. Long before construction day arrived, powerful digital systems were already shaping every outcome, predicting problems, and eliminating delays before they could ever appear. It begins with design, but not the kind drawn on paper. Engineers use intelligent modeling software that creates a living digital version of the building. Every beam, every connection, every load bearing point exists inside this virtual environment. The software doesn't just show how the building will look, it calculates how it will behave. Stress, vibration, weight distribution, and even long-term wear are simulated before a single physical part is made. This means mistakes aren't discovered on site when they're expensive and time-consuming. They're eliminated early when changes take seconds instead of weeks. Once the design is perfected, automation takes over. Machines cut steel, mold concrete, and assemble components with precision that human hands simply can't match. Measurements are exact, repetition is flawless, and quality stays consistent from the first piece to the last. Robots don't get tired, they don't lose focus, and they don't improvise. They follow the plan perfectly every time. That consistency is what allows thousands of parts to fit together seamlessly when they finally arrive at the construction site. But the intelligence doesn't stop there. On the day of assembly, smart machinery becomes the backbone of the operation. Cranes are guided by computerized systems that calculate balance, weight, and movement in real time. Lifts are smoother, safer, and faster because the machines already know the limits. Sensors monitor alignment down to millimeters, ensuring each section locks into place exactly as designed. What looks effortless from the outside is actually the result of constant data flowing behind the scenes. There's also a powerful layer of communication technology connecting everything. Engineers, supervisors, and operators stay linked through real-time updates. Progress is tracked live. If something shifts even slightly from the plan, adjustments are made instantly. This prevents small issues from becoming big delays. Instead of stopping work to figure out what went wrong, the system corrects itself as it moves forward. And here's what makes this truly revolutionary. Technology doesn't just speed things up, it makes speed safer. Traditional construction often slows down because risk increases with pace. But when machines assist decision-making and execution, safety improves. Loads are balanced correctly, structures are aligned precisely, human error is reduced. Speed and safety stop being opposites and start working together. Artificial intelligence also plays a subtle but critical role. By analyzing past projects, AI systems help optimize schedules, predict bottlenecks, and allocate resources more efficiently. They learn from experience, improving with each build. That means every fast construction project becomes even faster and more refined than the one before it. Progress compounds. What's fascinating is how this technology reshapes the role of humans. Instead of doing exhausting, repetitive tasks, people become supervisors, problem solvers, and decision makers. They guide the machines rather than competing with them. This partnership between human intelligence and machine precision is what unlocks a new level of productivity. This isn't about replacing workers. It's about empowering them. When technology handles the heavy lifting and precision work, humans can focus on coordination, judgment, and adaptability. That's where real value lies, and that's what keeps the entire system flexible under pressure. Seen together, all of this technology creates an invisible safety net. It catches errors early, maintains quality, and keeps momentum alive. The faster the build moves, the stronger that safety net becomes. Speed no longer feels risky, it feels controlled, and that's the real breakthrough here. When technology becomes a silent partner instead of a flashy tool, the impossible stops looking dangerous and starts looking inevitable. Because when intelligence guides every move, even a single day becomes more than enough. At this point, it becomes clear that what you're seeing isn't just an engineering flex or a viral headline meant to impress the world for a moment. This approach to building is quietly redefining what the future of construction looks like, not only in China but everywhere. When buildings can rise in days instead of years, the ripple effects go far beyond speed. They touch housing, cities, economies, and even how societies respond to crisis. Think about the global housing shortage. In major cities, millions of people struggle to find affordable places to live, while construction projects crawl forward at a painful pace. Now imagine applying this rapid building system at scale. Entire neighborhoods could be assembled in weeks. Costs would drop because time, waste, and delays shrink dramatically. Suddenly, the idea of solving housing shortages no longer feels like an endless debate. It starts to feel like an engineering problem with a real solution. The impact becomes even more powerful in moments of disaster. Earthquakes, floods, and conflicts displace millions every year, forcing people into temporary shelters that were never meant to last. With this construction model, permanent, safe housing could be built almost immediately. Instead of waiting months or years for rebuilding efforts, communities could begin recovering within days. Speed in this context isn't about convenience, it's about dignity and survival. Urban expansion also changes completely. Cities are growing faster than ever, and traditional construction struggles to keep up. Roads, hospitals, schools, and residential buildings all compete for time and resources. Rapid construction allows city planners to respond dynamically instead of reactively. Infrastructure can be built when and where it's needed, not years after the demand has already overwhelmed the system. There's also an environmental shift happening here. Faster construction usually sounds like it would harm the planet, but in this case it's the opposite. Prefabrication reduces waste, cuts emissions from prolonged construction activity, and uses materials more efficiently. Buildings can also be designed with energy efficiency in mind from the start, integrating insulation, ventilation, and smart systems before they ever reach the site. Sustainability stops being an afterthought and becomes part of the blueprint. Economically, the implications are massive. Shorter construction timelines mean faster returns on investment. Businesses can open sooner. Hospitals can treat patients earlier. Schools can welcome students without delay. Entire regions benefit from increased productivity simply because time is no longer being lost. When time is saved at this scale, it turns into economic momentum. This shift also forces the rest of the world to pay attention. Once one country proves that this level of efficiency is possible, old excuses begin to fall apart. Delays that were once accepted as normal start to look like inefficiencies. Systems that resist innovation begin to feel outdated. The global construction industry is being quietly challenged to evolve or be left behind. And yet, this isn't about copying one country or one method exactly. It's about adopting a mindset that questions why things take so long. A mindset that prioritizes planning, integration, and technology. A mindset that believes speed and quality don't have to fight each other. What's happening here is the early stage of a transformation. Just like assembly lines changed manufacturing, this approach is changing how we think about buildings. They are no longer static projects frozen in time, but dynamic systems that can be produced, adapted, and deployed as needed. The most powerful part is that this future isn't theoretical. It already exists. It's been tested. It's been proven. The only question left is how quickly the rest of the world is willing to learn. Because the nations that embrace this shift won't just build faster. They'll move faster toward the future. When you step back and look at everything that made this possible, the preparation, the precision, the coordination, and the technology, it becomes obvious that this story is about much more than one country or one building. It's a lesson, and the lesson is being quietly offered to the rest of the world. The question is not whether this can be done elsewhere. The question is whether others are willing to rethink how they build, plan, and execute at every level. For decades, slow construction has been treated as normal. Delays are expected. Budgets are inflated. Deadlines shift, and everyone shrugs as if that's just the way things are. But once you've seen a fully functional building rise in a single day, that mindset becomes harder to defend. The biggest barrier suddenly isn't materials or money, it's thinking. What this example shows is the power of committing fully to innovation instead of applying it halfway. Many countries experiment with new tools but keep old processes. They add technology on top of outdated systems and then wonder why results don't change. Here, the entire approach was redesigned from the ground up. Planning replaced improvisation. Precision replaced guesswork. Systems replaced shortcuts. And when everything aligned, speed became a natural outcome. There's also a deeper lesson about leadership and long-term vision. Achievements like this don't come from chasing quick wins. They come from investing in research, training, and infrastructure over many years. Engineers aren't created overnight. Neither are factories, digital systems, or skilled teams. This level of execution is the payoff for thinking decades ahead instead of election cycles ahead. Another takeaway is how collaboration beats isolation. Architects, engineers, manufacturers, software developers, and on-site teams didn't work in silos. They were connected parts of the same machine. Information flowed freely, problems were shared early, Solutions were built together. That unity is something any country, any industry can strive for, regardless of size or budget. There's also a cultural lesson hiding in plain sight. When speed is treated as a shared responsibility rather than an individual burden, performance rises. When people trust the system, they move faster. When they believe in the plan, they execute without hesitation. This kind of trust can't be forced. It's earned through consistency, competence, and clear direction. Importantly, this isn't about turning every nation into a copy of China. Every country has its own regulations, challenges, and realities. But the principles are universal. Plan deeply, build smart, integrate technology early, respect time as a valuable resource. These ideas aren't political, they're practical. The real cost of ignoring this lesson isn't falling behind in construction. It's falling behind in progress. Infrastructure shapes economies, housing shapes stability, speed shapes opportunity. Countries that continue to build slowly in a fast, moving world will feel the gap widening year after year. And perhaps the most inspiring part of all is this. None of these breakthroughs required new laws of physics. They required new ways of thinking. Everything you've heard is achievable with the tools that already exist. The difference lies in how boldly those tools are used. This story isn't meant to make others feel small. It's meant to show what's possible. It's a reminder that human potential expands when we stop accepting limits that were never real to begin with. Because once you've seen what can be built in a single day, it becomes impossible to believe that the future has to move slowly.